Hello everyone. Today we will be covering object oriented programming concepts. So we'll be going through all the object oriented programming concepts, and also we will be doing a lot of C sharp hands-on exercises. So it's going to be a master class. Like if you have some knowledge of object oriented programming or not, so this is a session where you'll get the deep overview and deep overview of object-oriented programming concepts. And in the end, we are going to do a hands-on exercise. So a lot of the definitions I have taken from this book, Object-Oriented Analysis and Design with Applications, is written by Grady Booch. I consider this book the Bible of object-oriented programming. So a lot of definitions are taken. I highly recommend that you do read this book. There are a lot of other books which have simpler definitions and more hands-on exercises. Here, a lot of hands-on exercises are on C++, but still I would, even though you don't know C++, I would highly recommend reading these books. He really goes down the philosophy of object-oriented analysis and design. So what is object-oriented programming? I took this definition from the book. Object-oriented programming is a method of implementation in which programs are organized as cooperative collection of objects, each of which represent an instance of some class and whose classes are all member of hierarchy of classes united by inheritance relationships. So what does that mean? So let's take a example of aircraft. Aircraft has a lot of components. So it has landing gear, it has engine, it has tail fin, horizontal stabilizer, wings. So if we look into the object-oriented analysis, airplane is made of components. So they all these could be made of same material. So in airplane components, we have engine, we have landing gear, we have tail fin. So all these have some common attributes which can go into airplane component. So we can see every within engine there could be subclasses. There could be jet engine, propeller engine. So we can see all these are all classes, and there could be 4 engine in the plane. So those engines are like objects of class engine. And we can see there's a hierarchy here. Airplane component is the highest one. Then we have sub components, sub classes like engine, landing gear. So what is object-oriented design? Object-oriented design is a method of design and encompassing the process of object-oriented decomposition and a notation for depicting both logical as well as physical, as well as static and dynamic models of the system under design. What does that mean is basically we are finding all the classes in the airplane, like what is the engine, tail, all those things. We are finding different classes in our domain. And when it talks about static and dynamic, a static and dynamic model, logical and physical, is talking about the UML diagrams. So in the UML, this is kind of a building diagrams. You can have class diagram, which is a static view of which is more you're seeing a structural view of the system. Then you can have object diagram. I have never used. You can have component deployment diagram, packages diagram. And then you have behavioral diagram. You have state machine diagrams. Again, I have never used in my career. Activity diagram is you are showing the flow of the mechanism, how the things are working. And so sequence diagram also I have used a lot in my projects. So these UML diagrams are good for documenting your system. They are good for if you want to communicate the complex idea with other people. So they are good for that. What is object-oriented analysis? So object-oriented analysis is a method of analysis that examines the requirements from the perspective of clauses and objects found in the vocabulary of the problem domain. As we discussed in case of plane, we all discovered what are the classes and what are the objects. Like engine is a class. Within engine, there are multiple instances of the engine. So that was a basic definition of object-oriented analysis. So question is like why this is so popular. I have been in industry for more than 20 years. My name is Vikas Keni. I'm a software architect. I'm TOGAF certified architect. So uh, object-oriented analysis, all big project, big enterprise project, you use object-oriented programming to design your business layer. The question is why it is so popular. Why every big project you use this analysis, design, and programming. In my experience, I have seen that when I have worked on the system where I was not using object-oriented programming. Basically, we were doing more procedure level programming. So one thing I have seen when you analyze classes, find out classes, and add methods to the classes, find out mechanism. Generally, your programmers are into smaller parts, and the benefit of that smaller part is more you can reuse your code. So smaller is the code. Like if you have for example, you have a invoice class, and all the departments are making invoices. So all the departments can use that class. So that way there's no duplication of in procedure level coding. Generally, I saw you used to write every all the code in one form, and there was no reusability at all. So that helps you to build your applications very on the big scale. Object-oriented programming means you can design your system in parts. That's how agile methodology we work. Means that's how design best object-oriented programming models evolve. They evolve over the time. So you can take some problem domain of your business, build object model for that, and you can scale it out. And it's very easy debugging because like invoice printing, you know where to go, where to print, and chances are if you make some changes to the printing method of invoices, uh, you not gonna create some problems. It will be center location, and all other components which are using that invoice will get the new behavior of printing. And another thing is real world problem solving. The software field, as we all know, is very, very complex. There's a lot of complexity. So designing software like based on a logarithm is difficult. In object-oriented programming, you find out, okay, real or abstract mm, things in your domain. Okay, you have invoice, you have sales, you have users. So it's very easy to map your object model according to your problem domain. So if there are so many benefit, are there any downside? What I have seen, initial effort is very, very high. You have to build your business layer. You have to build framework. So initially, you have to think through the design. So it takes some time, and if you are joining a newly joining, learning the framework takes some time. Learning how the classes has been laid out, how they are interacting with each other. That takes some learning. That takes some time to get familiar. So before I go further, uh, any question, Aditya? Any comments?
No questions.
So what are the concepts we are going to talk today? What are objects and classes? Encapsulation, inheritance, polymorphism, and abstraction. So what are objects? I an object has state, behavior, and identity. The structure and behavior are similar. Objects are defined in their common class. The term instance and objects are interchangeable. Behavior, when you talk what is behavior, behavior is how object acts and reacts in terms of its state changes and message passing. So if you tell invoice should be printed, you need to send a message to invoice that okay, it need to print, or maybe invoice has opened and is ready to be, you are ready to bill it, and there's a state change, it will get printed. So that's how it behaves. Either state should change, or you need to send some message to send them some message to do call its method. A class is a set of objects that share a common structure and common behavior. Most of the time I see example, they give you example. Class is like a cookie cutter, and objects are cookies coming out of object. Like in interview, what I tell is okay, like a animal is a class, and sorry, human, let's say person is a class, and because is one instance of that class, Aditya is another instance of that class. So that's how I define. So what are the different object oriented analysis method development methods? How you can find objects classes in your domain? Some is the some way, some say it's very simpler. Find out all the nouns, all the actors, all the events, all the mechanisms in your system, and create object model. There are other one. There's a CRC, that is cross responsibility collaboration. What you do is you prepare a deck. On the deck you write the class name and what is the responsibility of this class and how it is collaborating with other classes. That is one way of designing the classes in your domain. Then there's a domain driven design. In domain driven design, there's a domain expert who tells you what are the important actors, events, uh, implement, I would say, logarithms in your mechanism in your domain. And then there's a behavior analysis. Okay, so who's the initiator? Uh, what kind of behavior is happening, and who are the participants? So these are the three way of doing object-oriented analysis and design. Personally, I would say if don't spend too much time, I'll show you a little bit later. If just create some classes and classes, do some implementation if you have too much confusion. Because if you have written your unit test, object-oriented programming makes sure that writing automated unit tests is very, very easy. We'll go into a little bit later into that part. So you can always redesign your object model. Means good object models, good class design, good object models evolve over the time. So just make a first copy and keep refactoring it. Another thing is like always make sure your system is very simple. This is very good message or wisdom from the book. A complex system that works is invariably found to be evolved from a simple system. So always try to build some simple system and keep adding on that. So so that like if you start with a complex system, chances are you will get into a lot of difficulties. Persistence. So you have created an object. You created some invoice. Somebody placed an order, and order has some quantity. It some items were ordered. There's some cost. So those need to be saved. That is called serialization and deserialization. So let's do a exam. C sharp. Let's do a hands-on exercise. I have recorded it. Let me show you that exercise. We'll look into the class, object, and persistence. Mm. You can see the video, Aditya.
Yes, I can see.
So here's the person class I have declared in the business layer. It's the console application. So this person class will have three properties: name, age, and email. And I'm going to override the toString method. This will be I will be using serialization. So I'm toString. I'm returning the name, age, and email in one string. So let me go to my console application and get rid of this code. Let me add my business layer namespace using system, then declare my program class. As I mentioned before also, I have a code pilot installed on my machine. So you will see it generating a lot of code for me.
Yes. It can seems magic to new developer.
So I'm going to create a collection of persons so that these are the objects. I'm declaring multiple objects of the class person. So here you can see Alice is an object, Bob is object. They are instances of class person. And I'm going to serialize them into a file in a JSON format. Mhm. Sometime like Code Pilot is showing me, giving me code which I don't need, but it's a very great productivity tool. I'm going to create a method which will serialize this file. It's giving me all, I want to declare a method. I don't want to use anything from the drop down. Okay, so I'm going to write this serialize to file method, which will take two parameters, the collection of people and the file path. Let me, I'm writing a console message that it has been serialized to this file. And then I'm going to deserialize, read this collection into this deserialized people object. It's a collection. So let me write now these methods. Serialized to file. So basically, I'm taking the collection of people. Uh, I'm in JSON format. I'm writing to the file and it will be indented. So, and I wrote the deserialize function also.
So this entire serialization and deserialization method wrote by Copilot, right?
Yes, yes. So here I'm stepping through this my code. Collection is serialized to the file and now it's deserializing. And yes, the variable was populated. I have 3 classes from the file and let me run the program and let me see the console output. So we can see it read from the file and wrote it. Let's go and see our file. I'm going to my file location. Then I will go into the bin folder and debug. By default, it writes the file in this folder. Here's my people JSON, which has been serialized. Let me open using text editor. So here, all the collection of objects has been serialized into in JSON format into a file. So any questions so far?
So serialization can be happen to JSON, XML, any other format.
Yes, we can use any format.
And
Generally,
deserialization,
in real environment, in corporate world, we'll be saving it to database, and basically we write each property and write into the database. But we, if there's some need, temporary need, we can store into XML flat file, any storage.
so can we say that if we are storing object data to database, then can we say that we are doing serialization, and once we are retrieving from database, so can we say that we are
Generally,
deserializing?
we don't do serialization in like that way. Means generally means
We
uh, uh,
receive directly an object.
yeah. So means we are persisting the value, but we never use serialization. Like we, I think generally means nowadays generally this object relation mapping is a different subject. Now I think now our database design is very close to objects, but it may not be necessary. Your property name could be different and the database field could be different. You could be storing one object into multiple tables. So I think that's a reason we don't use serialization to save in the database, because you need control. Okay. Abstraction. So an abstraction denotes the essential characteristics of an object that distinguish it from all other kind of objects, that thus providing a crisply defined conceptual boundaries relative to the perspective of the viewer. What it means is abstraction. When we are looking at a plane, let's say a pilot, he's interested only making sure that plane is good to fly, whereas a let's say electrical technician, he's interested only in the electrical circuit of the plane. Whereas a fuel uh, person, he's interested only fueling the plane. So we can see everybody is looking plane from his perspective. Everybody, for a passenger, we are interested only sitting in the plane and taking us from one place to another place. So we can see, so all our abstractions are different. And so that's a very important thing to find if we are looking into the domain. What are the abstractions? Like in generally, again, I would give example invoice, salesperson, user. These are all abstractions. Encapsulation. Encapsulation is the process of compartmentalizing the elements of an abstraction that constitute its structure and behavior encapsulation serves to separate the contractual interface and of an abstraction and the implementation. What it means is a watch. When we see a watch, we are seeing only the time, dial time. Behind, underneath, what kind of mechanism is there, which is running, getting charged, making sure those all these three uh, keys are running or showing time properly. So that's implementation. Encapsulation is we are interested in only seeing the time, how its watch is running. Those are details. Those need to be hidden from us. So that is encapsulation. Encapsulation just show us the time using three keys, and how it's implementing, we don't want to know. And we don't want to show it to the other component because to the client because he's not interested in knowing the implementation. Uh, another will come little bit late, talk about interfaces little bit later. What's the advantage of interfaces? Any question on encapsulation before we further? So we
So
talked
here,
about abstraction, encapsulation.
so here we said that our understanding is we say that once we achieve abstraction, encapsulation is automatically achieved. Let's
Um, abs- so abstraction, you first found out like, okay, there is a, let's say, sales order. And then you, encapsulation is your sales order, what are other people are interested in knowing in the sales order, and what you need to hide from others. The like you're saving into some database and retrieving the value. Other people are not interested knowing. Okay, they want, okay, give, this is a customer, give us the sales order implementation. They are not interested how you are storing, whether you are storing in the database or XML file, JSON format, you know. So it's like you're deciding what you're gonna hide and what you're gonna show.
That makes sense.
Modularity is like which component you're no, you have sales order is there, you decided is public interface and what's private implementation, and now modularity is which component you're going to put. Generally sales you may put in a sales package. So this is a very commonly asked question, like modularity is the property of a system that has been decomposed into a set of cohesively and loosely coupled modules. So what is cohesive and loosely coupled? This is very common object-oriented programming interview question. So loosely coupled is means you when you're designing an application, you have, let's say, user interface, you have a business layer, and you have a data access layer. So if your user interface is coupled to business layer, and it should be loosely coupled. But what does that mean is like you should be using interfaces instead of using the concrete classes. That will interfaces will talk more little bit later. So that is loosely coupled. That you should be able to change the business, like not the business layer would not change. So UI, you may have Angular UI now. You may switch to React UI. So they should be lightly coupled to the business layer so that you can change your Angular implementation to React implementation without affecting the business layer. And cohesive is like you have a sales package. In the sales package, you will put the clauses which make sense. You may put a customer, you may put sales order, all those things in that package. Whereas, let's say, inventory related classes may go into inventory package. So cohesive is when you're putting classes together in a library, they should make sense. They should not be unrelated. That is cohesive. Inheritance. So object oriented. This is very uh, hard topic. Inheritance. in inheritance, like you have a invoice clause, and let's say you have a customer. Customer is very employee. Let's take employee. So employee is the base class. In within employee, you may have contractors, you may have full time. So those are subclasses. So these both contractors and full time employees, they get salaries. So they have some common structure. They have common behavior, that they get paid salary. They have first name, last name. So you can have a employee class and do define some structure and behavior, and then you can create a some uh, subclass which can inherit from the parent class. So there are single inheritance and multiple inheritance. Single inheritance, you can inherit only one class. Uh, in C sharp, that's another question. Can you have multiple inheritance in C sharp? The answer is no. You cannot derive from multiple base classes. Whereas if you are implementing interface, you can implement multiple interfaces. Typing. We say C sharp is a strongly typed language. What does that mean? So typing is the enforcement of the class of an object such that objects of different types may not be interchanged, or at the most they may be interchanged only in very restrictive way. So in C sharp, once you define something as int, it has to be int. You cannot assign a double value, but you have to typecast the value. Let's say in double you are putting int value. So you have int can go into double, but I think you have to cast it to double to make sure it works. Polymorphism. Last time we were talking about we were talking about C sharp interview, and we discussed polymorphism, and this is one of the toughest question I face. I was telling Aditya.
Yes.
So polymorphism. What is polymorphism? Polymorphism enables a single interface to represent different underlying forms. Polymorphism is of two types. One is uh, uh, one is what you
Compile
call
time,
the development compile time.
compile time. Yeah,
Thank you,
static polymorphism, and second one is runtime polymorphism or dynamic polymorphism. We call it.
thank you. So one is compile time. In compile time is where overloading and overriding comes into picture, and then there is runtime polymorphism. Most of the time in interview, I give example of runtime polymorphism. So let's go into example. I'm going to use the same example I used in the C sharp video. Do watch that video. I'll put the link down. So let me run the polymorphism video. So I'm going to declare a calculator class. This is more example of uh, compile type, compile time polymorphism. So I'll have a add method. So I can add another add method with different signatures. Here I'm creating add method from with three variables and different type. So let's create our main class and call these different methods. So I'm creating a object of calculator class. So I'm calling method with two parameters, three parameters, and double value. So this is an example of overloading. So let's now go into the um, runtime polymorphism example. I'm going to declare a animal base class. So I'm creating a virtual method which can be overridden. Speak. So I'm creating now derived classes or subclasses. Dog, which implements the animal abstract class and overrides the speak method. Cat class implements the abstract class. So I created an animal and assigned dog class to it and speak, and then assigning cat and speak. So this is example of polymorphism. Uh, I'm declaring a variable of animal class and assigning dog or cat. So since they are derived class, it can be assigned to that one. So last time Aditya asked me question, what is method hiding? So let's
Yes,
talk about method hiding now.
I have never seen use of this method overriding.
Overriding?
Overriding, we use in almost every project everywhere, but I
Uh-huh.
have never seen method use of method hiding. But still, people, this is a concept of
I
method
think
overriding.
when people want to give you hard time during object-oriented programming interview,
Yes,
if they don't like, they ask you this question:
and the
What is
people,
hiding? Override.
and the
So
people ask this question, what is method hiding? And
whether
since it,
they are giving you, the chances are this interview is not going to work. They are giving you a hard time. I'm joking.
so, I have never seen the use of method hiding, at least. But for me,
Generally,
it's
I stay away from inheritance. Means inheritance is like a little bit very tricky. I'll talk a little bit later. That's uh, why I
I
try
have
not
one.
to use.
This concept of polymorphism was very confusing to me also, uh, and still confusing, but now it makes sense.
Mhm.
Earlier, I was wondering why we call compile time, why we call runtime, and I was not able to distinguish. So
And
later,
I was always shocked. Like I was always wonder why I'm not a why my interviewer are not satisfied with my definition of polymorphism. Okay, let's declare a class. We create a business here. We call it base class. So we are creating a virtual method. Virtual is a C sharp keyword. It tells, okay, this method can be overridden. So I'm creating a virtual display method and and then show method. Let me create a derived class. So in this drive class, I'm going to override one function and hide one function. So let me inherit from base class. Okay. This is recording, so this display I did not override. Uh, I'll come back to it bit later. So let me add the reference of my business layer to my console application. And here now we are going to write some code to demonstrate the difference between overriding and hiding. So okay, I wrote the code base class and then drive class, I'm calling those methods. So one thing is like the third one you should see is I'm creating base class and assigning the drive class object to that base class. So here, okay, I'm going to fix the display. It should be override. Hmm. Okay, I'm going to fix this. It should be override display and I'm doing show. So first base class, I'm assigning base class and uh, calling those methods. Then I'm creating a drive class and calling those methods. And third one, I'm calling the base class and assigning a drive class object to that one and calling that. So the difference would be when hiding comes into picture, the difference would be in scenario third. Let's run it. Let me pause the video.
The first two are straightforward.
First one is straightforward. Second is straightforward. Third one, you see, I created a base class and I assigned it object of the drive class and overridden method, it called from the drive one. Whereas the one which is hidden one, it is hidden from the base class. So base class doesn't know that drive class has implemented a new method. It's showing from the base class. So
Exactly.
so that is the difference, kind of. It's a base class, means it's and not anti-polymorphism. According to polymorphism, in the base class, I should be assign the drive class and call those methods. So
Yes.
that's what it says. The documentation says. Means I have never used hidden method myself. The documentation says if you want to write some totally new implementation, then you should use new.
And here now one thing I would like to add here
Hmm.
at line number 17. So since here we are using base class one reference and we are creating object with the derived class. So
Hmm.
here for like we have concept of compile time polymorphism and runtime polymorphism. So at compile time we know by looking at code only that which method should be called, like function
Hmm.
overloading. We know in function overloading by passing the parameters, input parameters, we know that this function is going to get called. And same in the concept method hiding, we know
Hmm.
which method is going to call. In method hiding, always method is called by class reference, base class reference. And in concept of polymorphism runtime, it suppose we have here base class at line number 17, we are creating from drive class object, but since it if it can be different class, then that method will be get called. So here we are not sure that which method is going to call. So this is maybe why we call runtime or dynamic polymorphism.
Then
So this is my
interesting.
understanding.
Awesome. So what is the difference? Another popular question is in C sharp is what is the difference between interface versus abstract class? Interface is a contract between client and component where component exposes its functionality while hides its implementation. Abstract class, you can have both. Uh, you can implement code and it can have abstract methods also. Generally, the question will be asked in more tricky way that why you need to have a interface between client and implementation. The answer is if client is coded towards the interface, you can change the implementation anytime without client knowing the implementation has changed. He doesn't need to recompile. So that is the benefit of interface-based programming. So let me run a video, C sharp, where we going to show abstract class and interface. So we are declaring a interface, iVehicle. You have start engine, abstract method, stop engine. We have only the definition or signatures. We don't have the, only have the definitions of the methods, but we don't have implementation in the interface. So now we are going to create a class. Here I'm creating abstract class. In abstract class, we can create an abstract method and we can put some implementation also. I'm putting honk implementation. It's gonna write honk honk. So I have created interface and abstract class. As you can see, interface has only abstract methods, whereas abstract class has both abstract as well as L implementation. So car is going to implement the interface. It has to implement all the methods, start engine, stop engine. No, we will create another class, motorcycle. So this will inherit from the abstract class. So it's overriding the start engine, motorcycle started. So in the console application, we are going to write the code which will call these classes. So let's declare the interface, car, and assign iVehicle, assign car to it, and car start engine. And we can see the difference between vehicle, it's inheriting from abstract class. So it gets honk implementation in free since it's declared and declared in. Let's run it. And we see it that in abstract class, the drive class got implementation in free. Aggregation versus composition. Aggregation, you have has a relationship where the contained object can exist independently of the container. A library has books, but books can exist outside the library. So generally, must have seen your class. It has a very big hierarchy. There's a class within another class. There may be collection of classes. They may have nested. they have also classes. So so there are two patterns. One is aggregation, one is composition. Composition is part of. So in composition, like it's example of engine.
गेट बंद कर
Car
दो.
car has engine, but you cannot access engine outside the car. Car has more private implementation of engine. So that is the difference between aggregation and composition. So before I go to design patterns, so far any questions? Mm, we
Sir, one
discussed.
sir, one question now, and the people are asking in the interviews now about interface in abstract class, and now we have also default implementation in interface,
Mhm.
so we can put some code in for a method, so that can be used by class also. So they ask, we say that for abstract for abstract class we can put common code in abstract class, and derived class can use it. So now, and they have introduced some implementation. Interface can have also default implementation.
Oh, really? Means I have to check that. Explicit implementations.
So
That's interesting. Oh, good. I have to check that.
we can discuss it in the
Sure,
next
sure.
session.
So we discussed second part. We discussed abstractions, encapsulation. Abstraction, you are finding out interesting stuff in your problem domain, in vices. Encapsulation, you're deciding what other people gonna see and what you gonna hide. Modularity, you are putting them in components where they make sense. Inheritance is a mechanism which you can use structure and behavior of other classes, so you don't have to reinvent the wheel. One thing I would say, in inheritance, you should be very careful, because if you use inheritance, a lot of time I have seen the code become very, very complex. There are a lot of debate that inheritance breaks the encapsulation part, because you need to know the base class implementation. And I would say inheritance, be careful with that. It can create a lot of complicated code. Interfaces are awesome. We'll look into quickly. Typing, we saw, okay, C sharp is a strongly typed language. You have to declare the type, and once you declare the type, you cannot assign other, you can assign some other types only under very restrictive way. Polymorphism, we discussed design time and compile time and runtime polymorphism. Interfaces, interfaces are very, very important in object oriented programming. There was a I have lost interviews because I knew everything in I knew everything other than interfaces. And like Aditya, I went for interview. I was asked some 40 questions. Out of 40, I answered 39. And final question, he asked, what are interfaces? I did not answer, couldn't answer that time. That was long time back. I lost the interview. That time I couldn't understand why did I lose the interview. Like out of 40, I answered 39 questions. How could I lose interview? Because I did not know interfaces. No, I know.
So
It's a
we can
very, very,
understand how this important question
very,
is.
very important question. I wish he could have asked me first and let me go.
It has lots of weightage out of
It
40
is.
questions.
Yeah. So another thing, now you will see why interfaces are very, very important. So as I discussed in object-oriented programming, Aditya, you agreed object-oriented programming people don't use, like it's very difficult initially, right? Is that correct? Like a lot of people end up using, not using object-oriented programming. They just write all the code in one place and that's it.
And maybe they are using object oriented concept, they are not using perfectly or
Perfect.
absolutely, they are using
Why it is? Because it's very difficult, right? Object means a lot of object-oriented programming initially is difficult. It takes a lot of years of experience to get comfortable with figuring out where the classes goes, where the mechanism go, what defining the boundaries, how they work together, visualizing. So so there were four guys, and they think, oh, we have a serious problem in object-oriented programming, that there is a lot of difference between newcomers and experienced people. Can we reduce the gap? So they came up like a lot of time we are solving the same problem over and over. Why don't we come with design patterns where we know there's a problem and there's a solution, so that people who are new to programming, that they get knowledge. I think this design pattern was taken from housing industry. In housing, you have same patterns. So somebody came with this idea: why don't we come solutions for recurring problem? So these are design patterns. That's one another very popular question. I wanted to include it singleton also, but I ran out of the time. So let's run a demo on what is the design pattern is. Let's run a quick demo on factory design pattern. Aditya, we generally close at 8. I think we're gonna run some more time. Do you have
Yes,
time? Are you
yes, I have time, sir. I have
okay?
time.
So I think we're gonna run 20-30 minutes more.
Yeah, yes, sure, sir.
So okay, let me run the uh, our factory design pattern video. That video. So in this in design pattern, we're going to demonstrate test-driven development, how you write automated unit test, mocking. We are covering a lot of dependency injection. So this is one of the very important exercise. We're going to demonstrate a lot of important concepts: dependency injection, dependency mocking. Have you used mocking, Aditya, in your project?
No, sir, not yet.
Okay, so you're gonna learn mocking in this one. So
I've
let's
heard but never used.
use it. So let me create our business layer. You have been asked this question, design pattern. Do you know design patterns?
Yes, sir. I have been asked these questions. Yeah.
So generally, which design patterns they ask you?
And like I tell them that I have used dependency injection, factory pattern, and singleton. I only
Singleton.
know these two, three pattern only right now.
Miss, there are I don't know how many total are there. Only 4, 5, 6 patterns are really useful. Most of the patterns you never use, but they are good to know, you know.
Yes, sir.
So I'm declaring an interface called iNotification service, which is going to have a abstract method. It's going to send notification, take message as input. So now let's implement the concrete classes for this interface. So this email notification is going to implement the interface, iNotification, and okay, this is email notification. Let me implement another service, SMS service. So this is also going to implement notification service or SMS. So we declared one interface and two notification service and created two services. One is email and another one is SMS, which implement this interface. Now we are going to create as a part of factory design pattern, we are going to create a factory class uh, or manager. We call it notification manager. So here is an example of dependency injection also. So this is called constructor dependency. In constructor, we are taking the service, notification service as the interface, and then we are calling the method in manager. So this factory manager, factory class is responsible to call the right service uh, to send the message. As the end user, we don't know the which service is being called. I don't like this folder, so I'm removing the folder, add the project reference. Mm, Let me remove this method. So here is the main class. I'm creating notification manager, and first I'm creating a new SMS notification and sending notification hello world. Then I didn't like the code pilot code, so I'm writing my code now. So I created email service and SMS service, gave them to the interface. I'm giving the object of the concrete classes. And then I'm going to call the factory factory class to call the right component. So in if you saw the manager, I'm using the interface. So that is example of dependency injection. Instead of factory class creating its own objects, it is taking interface as a parameter. So that's another very important thing is very important concept of dependency injection. If you want to see more ASP.NET, watch my C Sharp, how to ace C Sharp architect interview in details. So here we're going to talk a little bit. So here you can see the notification manager. So let's now create our test project, automated unit test project. Generally in test-driven development, you first write the test and then you write the code. But in our case, we're going to write the test now. And why its example, why dependency injection is very, very important. And we are going to also talk about mocking concept, mock objects. We are going to use mock library to create mock objects. Let me rename this test. Notification app test.
Sir, you have kept the naming convention absolute perfect, sir.
Right. Notify. One part I missed return. What does it return? So, so I'm going to create a mock service for notification, because in real world email message, I may have to set up the email message, message box, which may be difficult to set it up and write my test code. So I can mock it. Uh, I'm adding the business layer reference to my test project. So let's add the mock library for mocking the objects. So go browse MOQ mock. So this is
Yes,
very
you are, sir,
popular.
adding, sir, this Nugget package manager, sir,
Yeah, yeah.
reference.
So for mocking, you need this mock framework. So what mocking does it create a I notification, it create a fake object. So we can our test our notification manager without worrying about the mail service.
Okay.
So giving mock object. So I'm mocking the I notification service, and then verifying that that call was made to mock object at least once. I didn't like the naming convention, S was small, so I refactored it, made it bigger. Okay, let me run the program. But actually, that's not what I wanted. I wanted to run the unit test. So you can see the text explorer in the left side.
Yes,
I
sir.
will I'll put a breakpoint, and so here is my test. Uh, notify call send one. Let me debug it. So you can see I'm mocking the notification service and giving it to my notification manager, and all my assertions are verified, and the test passed. They're awesome. Test passed. So Let me pause the video. Any question, Aditya, on
So
mocking?
I didn't understood this full. Could
Sure,
you
sure,
explain 1 2 minutes on this
sure.
marking in test? So, sir, this is one another way that we can achieve dependency injection. Last time you explained that we can achieve
Yeah,
dependency.
mocking. Why you need to do dependency injection for mocking? Let me open the project. Serialization method of factory console application. So in notification manager, we created a dependency injection pattern. So here we are taking interface and it's calling the interface method. So what is the benefit is like if you go into the test, 1 minute. Aditya, can you
Yes, yes,
take over
yes.
for
Sure,
one
sure,
minute?
sure.
I
Yes,
just
yes, yes.
need to open the door. Take over.
Okay.
Please. I am back.
Okay, thank you, sir.
Yeah. Aditya, like email service. In real world, email service may be very hard to create. You have to have the
Lots of
box,
dependency.
all the setup. So, but you want to test your manager service, the manager class. So, what you do is you create a mock of iNotification service, and this is the you create a object like you created a mock service, and then you pass the object to the notification manager. So basically, and then you pass the message and you call the method and you verify that send notification has been called once. So basically, email service you may be very difficult to set up. So what you do is you fake it, you make a fake object, you test your manager class, and you say, oh, I need to call this email service, and email service was called once. So mocking is a kind of mimicking. It's like you can think of simulation.
Okay, super.
It's a simulating the email service for you. Like in simulation, you fly the plane. Actually, there's no plane real. It's a all
Yes.
fake thing, right? But it gives you, oh, you are flying, you are in the air, engine started. So this is what it's doing. Like this is a simple one. It's this interface is just sending message. So it's a kind of simulating. Okay, send message was done from the email. Did it make sense?
Yes, yes, makes sense, sir. Understood, sir. This concept.
So this is the why dependency injection is important. So you can mock during during testing.
Yes, sir.
And another benefit you get dependency injection is that you implement interfaces. You make sure you are lightly coupling your presentation layer to business layer. Interfaces we saw object-oriented programming. It's all based on interfaces
And because of this use of interface and dependency injection, we can directly mocking here easily. Otherwise, we could
easily.
have trouble.
That's the main reason you do dependency injection. And lightly coupling between the layers you get in free.
Exactly.
I want to cover this. So I highly, this is like object-oriented programming. I said this Grady Booch is the Bible. And design pattern, I have two design patterns book. One is Gang of Four. It's a Bible. Again, examples are C++, but you should read it. It's a must read if you want to be a designer, architect. They are great advice, design advice. I wanted to include again, maybe some other time we will include that. If you want some easy, fun thing, I say you should buy both. To understand thinking from these are the people who came up with the design patterns, Gang of Four. What they were thinking, you should read that. And this is more friendly implementation that you want to read. I have reviews of both book on my channel. You can search it those. Maybe I'll put in links also. So dependency injection, that's what, like, we talk about dependency injection. So inside that manager classes, we could have taken a parameter and created the classes inside the object. But the dependency injection is uh, you provide object don't create the dependent objects themselves. They take through constructor, you provide them. So that's the dependency injection. And we saw it's mocking. So why you need mocking? As said, in real world, uh, s- creating object could be very very difficult. Like email service, you have to set up email service. uh, you have to implement the email box, all those things which is cumbersome. And at the same time, you don't know the email has gone or not gone. There's no way you can control. Whereas the interface, by mocking, you can test your assumptions. Another example could be, some object takes too much time to create. Again, you can mock it. Some object you may be calling from some other service, some authorization, authentication code. Again, you don't want to write those kind of slow APIs. You can mock those. So mocking is very very important concept, and dependency injection is a very very important concept. So
Yes.
this is a most mocking dependency injection is like, last time I was in the job market, everybody will ask it. And if you can answer this question, you got the interview.
Sir, and we can save lot of time and lot of resource also by mocking object, right, sir?
Objects. Exactly. Exactly. So let's do a case study. Yeah, I think this is very popular case study. You have to design a parking lot. So parking lot, I think this is a Amazon interview. This is a Amazon interview. I think they used to, I don't know whether they are still asking. They used to ask people to design a parking lot. So in this one, you will learn more inheritance, polymorphism, and encapsulation. So this is the problem. Problem is you have to design a parking lot system that supports multiple type of vehicles, cars, motorcycles, and trucks. In the parking, you will give a slot to you when you go to parking lot, Aditya, they give you ticket, right? And you take a slot. Sometimes they give number 14, you go. That is your number 14. They give you a ticket. And when you so depending bikes, they may charge you less. Cars, bike may they charge you $1. Cars, $5. Trucks, lot more than
Yes.
cars and motorcycles. And when you're done, you go to when you are taking your car out of the parking lot, you give a ticket to the clerk. He calculates how many hours you have been in the parking lot and charges you the money. So what are the requirement is it supports parking and unparking of the vehicle. Uh, Different type of vehicles may require different slot sizes, and because that's why cost is different. Bike, you need less space.
Yes.
Bike, you need less space. Uh, cars you need more space, and trucks you need lot more space. And you need to calculate the fee based on the duration and vehicle types. As I said, bikes you may pay less, cars you pay less, may more. So your system should be extensible, new vehicle types, and code should follow principles like reusability and modularity. So just I put a image of a parking lot. So what are the objects you see here from the problem domain? Yes. So what are the things we have to design? What are the classes here, Aditya?
Yes, sir. So I see here like vehicle class can be categorized into different class
Which
like
one?
car. Like we can create one vehicle class and it can be categorized further like
Beautiful.
car, truck.
Exactly. So that's a example of inheritance. Definitely we need a parking lot, which has parking lot has different slots to in the parking lot, and the car will be parked on a slot, and when it will be also removed from the slot, and you have to pay the money based on like how many hours you were there, based on the vehicle type. So this is a like little bit example. Okay, you have a parking lot which contains slots, and slots hold vehicle, as you put it very nicely, Aditya, that under vehicle you can have car, motorcycle, or truck. So Aditya, like shall I run the video or just go
Yes, we
through the
can run
code?
this. We can run this video. That's possible.
You video.
Yes,
Okay.
yes, sir. It's very interesting. I have
You
never
say
been part of
Amazon
this type of
real interview
complex.
case study.
Yes, sir. Yes.
This is 10 minutes video. Mhm. Yes, always create a new business layer where we put our business logic. So as Aditya, you said, like let's create our abstract class vehicle. You have a license plate and type. Just create a constructor method. So I created the car. Let's create the motorcycle class now. Will inherit the vehicle. Sometime code pilot puts a lot of unnecessary code. And finally, let's create our truck class. Implements vehicle abstract class. So we are seeing inheritance in the picture.
In the live picture.
So slot. We saw parking lot has slots, and most a lot of times slots have a ID. We need to find out whether it's occupied or not. and what slot has a vehicle, which vehicle is parked. So this is first initialized, is occupied false. So when we park the vehicle, uh, so is occupied, state change is happening. Uh, the message is coming that this is a vehicle and it has been parked. And when you remove the park, again state change is happening. Is occupied is false, and you remove the vehicle, set it to null. So of course we need a parking lot which has all the slots. So this is a container class for the slots. So here we are initializing slots. So parking lot, we are making it flexible. So we are telling how many slots this parking lot has. And then we are creating a park vehicle, where vehicle is finding the first empty slot and parking it there. Move vehicle. So we need to calculate the fee also. Here's our fee calculator. Code pilot is suggesting the code for me.
Yes.
Yeah, I have to fix the type. It's giving vehicle type, but actual property is type. So here it's calculating based fee calculator based on the car. Is $2, $5. I went back to the requirement to see whether there's any uh,
So
uh, cost
I
for each car
okay.
is flexible.
Great. Yes.
There, so yeah, it's cost. Bikes is $1 and cars are $2 and truck is $3. So no, let's write our code, populate these classes with objects. I didn't like my business layer name, parking lot. I'm going to rewrite it, rename, because my project name is also parking lot and
So
that class is also parking lot. So I'm renaming as, and this was the toughest part to come up with the name for that one.
yes.
So I put it public parking lot.
I also get confused most of the time.
So I'm refactoring, renaming it public parking lot. Do you, Aditya, you use refactoring capability from the Visual Studio? Like
Yes, sir.
rename?
Like
Awesome, awesome.
renaming change. It helps.
Beautiful.
It changes at almost every places.
Sure, sure. So there's a car, motorcycle, truck. I'm parking in the parking lot and then removing them. Unpi Code pilot is writing code and remove vehicle, remove vehicle, remove vehicle. And I need to calculate the fee also. Remove vehicle. I didn't like this, that remove vehicle is taking vehicle. Instead, it should be taking slot. Means when you are giving or asking him which, giving him a ticket to charge you, there will be slot number. Like he would not say, "Oh, one car is gone. This slot is open." So when I need to know when car was parked, it was went to which slot. So I'm removing vehicle from slot 1, ID, slot 2. That's what I didn't like the calculation time there. So I'm removing that. I'm giving that duration inside this program. So let's see, all these vehicles were parked 3 hours before, 3 hours before. Some more console.write line. So here I'm calculating the fee. Okay, let's run our. So here for motorcycle $3 per 1 hour, car is 6 and truck is $9. Yeah, that concludes our uh, case study. Any question about case study? Do you want me any question about case study?
So can you go back to the slides?
Sure, sure. I'll go to slide and parking lot solution is here.
So here, sir, we demonstrated on the one step back, sir. One here, sir, and the in the requirement section, and the second option, non-functional requirements.
Mm-hmm.
Code should follow principles like reusability and modularity.
Mm-hmm.
Could you explain it more, sir?
So I think object-oriented program, I think that's what it's telling you, use object-oriented programming concepts, because in object-oriented programming, you will be using reusability. It means a vehicle we, tomorrow is, if there's a new vehicle, we can add a vehicle.
Okay, sir.
And
And
yes,
modularity, sir.
modularity, again, modularity, in this case, modularity, I think, I would have said modularity is like cards we put in one library, public public parking lot, and could be in different library. Fee calculator could be in different library. So this was a very small example to talk about modularity, right?
Okay.
Uh,
So I thought we have different one parking lot business layer. So
mhm.
I consider like it's a one module, and if you create
Module.
one
That's what I'm saying.
module,
Parking, yeah. This could be parking lot could be one module. Fee calculator could be different module. In fact, we put in the business layer. Basically, anybody can use this business layer, which is reusable and modular example kind of thing. Means and they can be broken into more granular. Car vehicles could go into one. Uh, any other question?
so,
So let's quickly summarize what we went through.
so
So today we discussed object-oriented programming. It was a kind of a master class where we went through a lot of concepts and we had C# exercises, and in the last we did a case study. So we started with a lot of definitions were taken from this book, and we talked about the definition, gave an example, what is design, what is object-oriented analysis, what are the benefits, what are the costs, core concepts of object-oriented programming, uh, objects and classes, how you can design your object, what are the different methods of designing objects, how we had a code and we did a hands-on exercise, how you can save your classes. Then we talked about very powerful techniques of abstraction, encapsulation. Abstraction, we find out some uh, important abstractions in the system. Encapsulate, we decided what we're going to show and what we're going to hide. Modularity, we put them in components where they make sense. Inheritance, we can reuse structure and behavior of the classes. Typing, we talked. Polymorphism, we talked about design time polymorphism and runtime polymorphism. We talked about interface, why it's so important, what is the difference between interface versus abstract classes, aggregation versus composition. We talked about design patterns. In design patterns, we talked about the importance of interfaces, why design pattern, why dependency injection is important. We discussed about mocking. There was a exercise about mocking. And finally, we had a real case study. This is asked a lot of Amazon interviews, design a parking lot. So that concludes our workshop. Thanks for joining us. Good night. Bye bye. Hey, Josita.
Yeah, sir. Thank you, sir. This was a really great session, sir, and it went really.
I also had a great time. You can see I'm very passionate about this.
Yes, yes, sir. I can see, sir. You are very passionate and
Good night.
good night, sir. Bye, sir.